Greetings everyone. Today we're going to explore matrices. We're going to start off with some basic operations, how to name matrices, what are their dimensions. Since this is a new unit, please make sure you have your divider. If you don't, just leave a page before you start taking notes. So you don't need to write this down. Let's just review. We're going to talk about the dimensions of a matrix. We're going to add or subtract matrices, and we're going to multiply a matrix. Let's go over a few key definitions as far as what is a matrix. A matrix is a rectangular array that is used to arrange numbers into rows and columns. So basically, it's a mini Excel sheet is what we're doing here. The order or dimensions of a matrix is always the size of the matrix. So you most commonly would say dimensions, but you may just generalize and say, what's the size? To talk about the order or the dimensions, it doesn't matter what you count first. So when we talk about rows, we're talking about how many going left to right. And when we talk about columns, we're talking about how many up and down. The way I remember that is rows, I think of water, like rowing a boat. So how many left to rights are we making? And then columns, I think of Roman columns. So how many up and down dimensions do we have? And then you can choose to write this down or not, but just talking about if two matrices are equal, they're only equal if their dimensions are equal and the elements are in the same places. So really they have to be exactly the same. All right, so let's clarify in this example stating the dimensions of the matrix, which we discussed on the previous slide. First, we want to take a look at rows. I have row 1 and I have row 2, therefore I have 2 rows. And then we look at columns. We would refer to this as column 1, column 2, column 3. You need to know just how to identify them. So if I ask you what's the value in row 1, column 2, you could tell me that it's 4. So we have 3 columns. The order matters. It's always rows by columns. You always put an X in the middle, and the order matters. Let's talk about operations of matrices, specifically adding or subtracting. So basically, you add or subtract the corresponding cells of each matrix together. So if I'm talking top left, I subtract it from the top left. If I'm talking middle bottom, then I subtract it from the middle bottom. So in order for this to work, matrices need to be of the same order. If not, the answer would be undefined. So they have to be the same dimensions or size in order to subtract or add. If they're not, you don't need to do it. You just say it's undefined. So a couple of examples. I'd take a moment to pause the video and write the question down. Feel free to try it and then we'll check our answer. So first of all, I would notice that the dimensions are the same. So yes, I can actually add these. So now I know that my resulting matrix is going to be of the same size, which means I should have 3 numbers on top, 3 numbers on bottom. So if I fill it in, -2 plus -9. So we add the top left first, so -11. And we go through this process again. 6 plus the 8, right, gets me to 14. And we look at 10 plus 10 gets me to 20. And then we look at 12 plus 23, it gets me to 35. -3 plus 0, -3. And 1 plus 2 gets me to 3. So, I mean, it's easy, right? You're just adding the ones that can be added together, which are the ones that are in the same location. All right, so the same holds true for subtraction. If you're dealing with matrices, they have to be of the same dimensions or size. And if you have 3 by 3 for your dimensions, you should have 3 by 3 on your final matrix. Just watch your signs when you're subtracting. So 6 subtract -9, so that's going to get me to +15. 4 subtract 8, -4, so I'm just going to zoom through. 9 subtract 10, -1. Then we have 9 subtract 23, -14. -3 subtract 0, -3. 8 subtract 2, 6. Negative 5 subtract 21. So what do we got there? We've got 16. Oh, wait. Whoa, I'm going the wrong direction. Sorry. Negative 5. Oh, my goodness. Negative 26. Where am I going? Negative 2 subtract 7. So negative 9. And 4 subtract 0. Those 0 ones, of course, are going to be the easier ones. Okay? So easy process, easy idea. Just watch out for like simple errors, like what I was doing here, right? We know our facts. We know the process. Just slow down. Don't rush too much so you don't make a silly error like that. Let's talk about scalar matrices. So scalar matrices, basically, you're multiplying the contents of a matrix by a number. So you don't have to write this down, but just think of it. If I'm distributing into parentheses, every term in parentheses gets that distributed to, right? So the same idea with scalar. So in this example, that means every single piece gets multiplied by 2. So it's just like, think of it as distributing. We don't call it that. We call that a scalar. Keep the dimensions the same. Keep rows, columns. So if I started with 4, I'll end with 4. And then we multiply out. So 2 times negative 2, negative 4. 2 times 1, 2. 2 times 0, 0. And 2 times 7, 14. That's all it is, folks. Matrix equations. Here's where you might need to slow down just a tish. We treat matrix equations like regular equations. We're still solving the equations for x and y. What's easiest though is to make sure to pull those equations out so you can actually see what you're doing a little bit. Let's look at an example. So in this case, I've got parentheses to show that scalar is on the outside. So I literally would write down every piece. So I have the 3 is going to affect everything. Top left, top left, top left. So I would take that out and I would say, okay, I have 3 parentheses, a 5x plus a 3 closed parentheses equal to negative 21. Okay, so all I did was pull all those top lefts out and any scalars. And we're going to solve. I'm going to set up the next equation. So I have a 3, a scalar, parenthesis, a negative 2 plus a 7, and it's equal to 15. Well, wait, there's no variable there, right? So if I check, negative 2 plus 7 is 5, 5 times 3 is 15. Okay, so if there's not a variable, it should be a true statement. So there's nothing really to show. You don't have to prove that to me. So for example, if I look again, I've got a 3, a 6, a negative 5, a 3. I'm not going to end up solving for anything, so I'm not going to write that one down. But now I've got a 3, a negative 4, a negative y, a negative 24. This one matters. So 3 parentheses negative 4 plus negative y equals negative 24. Okay, so I pull the equations out and then I solve them. So let's take a look at the x value. I've got a 15x. I'm distributing first. Of course, there are many first steps you could take here. It's up to you how you will go about that. So we end up with x equals negative 2. And in our second equation, I end up with, let's see what we got, negative 3y, negative 24. I'm going to add 12 over, which gets me negative 12. And then if I divide, I end up with positive 4. Okay, so the nice thing is you can still check your work. So if I was to plug 4 in for y and I was to plug negative 2 in for x, it should be true. So 5 times negative 2 is negative 10. Negative 10 plus 3 is negative 7. Negative 7 times the scalar of 3 gets me to negative 21. So I checked my work, just some mental checking there. In the orange, I have negative 4 plus negative 4, which is negative 8. Okay, that sign carries on to that negative 4 there. Whoops, I use orange. So negative 8 times 3, negative 24. So I'm confident in that answer. Okay, so nothing new other than the way it looks. Okay, so if you don't like the way it looks, take that equation and bring it out, then it's nothing new. All right, everyone, those are the basics of matrices. So a couple key things, reminders, you're going to need to know the dimensions and how to state those correctly. Remember, order matters. We also talked about basic addition and subtraction. We talked about scalar multiplication as far as distributing that value into the matrix. If you have any questions, make sure you ask or stop by the Sabre Center. And until next time, have a good one.